Hi and welcome back everyone. Today we're going to be constructing a 1 minus alpha times 100% confidence interval for mu. This is called a t-interval on your graphing calculator. Let's look at the assumptions. So we can do this provided that, first assumption here, the sample data come from a simple random sample or randomized experiment. The sample size is small relative to the population size. Now we say little n is less than 5% of big N. The data come from a population that is normally distributed, or the sample size is sufficiently large. We said sort of that golden number is 30 for the central limit theorem to kick in. So sufficiently large is, greater than or equal to 30. And the construction of the interval itself here, you're noticing, is going to be x bar minus t sub alpha over 2 with a certain degrees of freedom. And respectively, the upper bound on the confidence interval would be x bar plus t sub alpha over 2, s over root n. Okay? And just remind you that the degrees of freedom would be n minus 1. Okay, let's go ahead and read a problem. Try this together. We're going to use technology and also try and do it by hand. Okay, so here's the problem. We are told to construct a 99% confidence interval about the population mean weight in grams of pennies minute after 1982. And says, should we use T procedures? So let's just kind of make a mental checklist. We're assuming this is a simple random sample. Sigma's unknown. We've got a simple random sample. It's small. It's a small sample, so n is less than 30. Have we checked for outliers yet? So no, but we could. I'm going to put it in the calculator in a moment and make a box plot, but outliers, we'll see that there are none. So we're looking good to use T procedures, okay? Now I'm going to hit pause and retrieve the formula for doing that by hand. And hopefully, you did as well. So we know that the formula then, if we're going to construct the confidence interval, is x bar plus or minus t sub alpha over 2 with a certain degrees of freedom. You'll see there's 17 observations here, so 17 minus 1 is 16 degrees of freedom. So 16 degrees of freedom, little less over root n. So your t-score, I just want to erase that little comma there. So your t-score, you'll multiply that by s over root n. Okay, so hopefully at this point you're thinking, gee, I need to find my sample mean, I need to find my sample standard deviation, and I know my sample size. Let's go ahead and use the technology to help us. And of course, you would look in the back of the book for a t-score, with 16 degrees of freedom. All right? So I pull up the calculator. First thing I do, I just want to show you, I put the data in L1. So you'll see my data is in L1. I'll make it a little bit larger here so you can see it. Okay, then I go second stat plot. I look at, and this is good review for the final, I look at a box plot. So I highlight the one that says modified box plot, L1, zoom stat, will show me my box plot. There it is. I see no outliers. Okay. Then stat, slide over to test, slide down to T interval. Hit enter. And it says, up top here, it says data or stats. Well, I'm going to highlight data because I actually have data. Then I have to tell it what list. So let me shrink this so I can get it. L1, I have to tell it L1. Oops, I must have hit something there. Try that again. Tell it L1. And then tell it your desired confidence level. So here we're running, it said construct a 99% confidence interval. So I would have to key in 0.99. Hit calculate. And it's thinking. Let me stretch this for you. You can see it. Okay, so you see it reports back the interval, 2.45, comma, 2.4, I'm rounding, comma, 2.48. And it tells you the sample mean, x bar is 2.46, tells you the sample standard deviation, 0.0177 about, and it tells you the sample size is 17, okay? It did not tell you what that critical value of t was. That I'm going to let you practice. I have podcasts on how to use your t distribution, so I'm hoping you know how to look up a t-score. But the main thing is, once we have this interval, the main thing is interpreting it. So let's practice making a sentence. So then we can say, we are 99% confident. Remember, this is the inferential part of statistics. So we are 99% confident the true population mean, or the population mean, weight of pennies minted after 1982 is between those bounds, between these bounds. So, you know, it's between 2.45 grams and 2.48 grams. Okay, so that's how you would interpret that. And a lot of people say, what in the world does that level of confidence mean? That means that if I was to go out and gather a sample of size 17, and you were, and 12 other people were, if we would repeat the experiment 100 times, 99 out of 100 of the similarly constructed intervals would contain the true population mean. So it's a high level of confidence. Okay, with repeated experimentation, that means that almost all of them would contain the true mean. All right, hope that helps. And certainly practice finding the t sub alpha over 2 on your own. In our book, you just look up the degrees of freedom, which would be 16, and you look up how much area is in the upper tail, which would be half of 1%, so 0.005. And actually, just to help you out there, I'll just write that as a reminder. A lot of people get mixed up with the language. If you are looking for t sub alpha over 2 with 16 degrees of freedom, let me just draw that for you. You're trying to be 99% confident. So you have 1% left to share between the tails, right? So 0.01 cut in half is 0.005. 1% means 0.01. So you know you have 0.005 area in each tail. So the way our book works is it says area in the upper tail on the t distribution. So you'd look up 0.005, and then you'd look up your degrees of freedom, which is 16, and you will find the critical value of t. You would find that t sub alpha over 2 that you needed in the formula. So that's just a little reminder. Okay, good luck out there.